In this video, I want to walk through 3 trig identities and show how we approach these questions so that we can prove that the left side equals the right side. That's how trig identities are set up. They're actually going to give you a formula like this one and they'll say prove. I want to focus on 2 major techniques that we should use for all identity proofs. The first I'm going to call structure, and the second I'm going to call trig ratios. And what I want to do with these 2 ideas is use the fact that it's a trig identity to our advantage. So what we've got here is we've got tan theta sine theta plus cos theta equals 1 over cos theta. They're telling us that the left side equals the right side. We've just got to prove it. So let's use that to our advantage. First step is going to be deciding which side to work with. And what I would always suggest is use the side where there's more stuff to work with. Clearly there's only one ratio on the right side. We've got a bunch of stuff happening on the left, so I'm gonna choose to work on the left. Left-hand side equals. You always want to let your grader know what side you're going to be using. Now, before I kind of start just trying things and moving things around, here's where I want to look at these 2 things. So the first is structure. I can see on the left I've got sort of 2 trig ratios here multiplied plus a different ratio added. And what have I got to end up at? I've got to end up at one fraction, right? One term together. So I've got 2 terms added on the left, 1 term where I need to get to. Well, that's a perfect example of a change in structure, right? How do we get from 2 terms added to 1 term together? We've got to add the 2 terms. Okay. That's going to require a common denominator if we're in fraction form. So first thing I'm going to do is change tan theta to sine theta over cos theta times sine theta, which is still there, plus cos theta. So again, I've got my 2 terms added. One's a fraction, so this is sine squared theta over cos theta. I'm just multiplying this in. You can think of this one as over 1 if that helps you see it better, plus our cos theta. And again, this cos theta is over 1. We just don't write that. So again, 2 terms added together to get 1. I've got to get a common denominator, which is going to be cos theta. So this is already all set, plus this will become cos squared theta over cos theta. I got that by just multiplying top and bottom here by cos theta so that I would have a common denominator. Great, now we can add these together and get our single term that we're looking for, sine squared theta plus cos squared theta over cos theta. So now all of a sudden we're in one ratio, so our structure is all set because we're in the same structure or form that we want to be to prove that it equals the right side. Now we can cheat even more by looking at what we need. Well, we need a 1 on top, a cos theta on the bottom. Well, I've already got my cos theta on the bottom, so I don't want to touch that. We're good to go there. Hopefully this jumps off the page at you, but even if it doesn't, you should be able to see, well, if the denominator is correct, the numerator should also be correct. And let's confirm, sine squared theta plus cos squared theta, we know that equals 1. So this equals the right-hand side, and we've just proved it. So by focusing on the structure, that almost gave us no choice but to put them together. We didn't even really have to think, oh, should I, change sine squared theta into 1 minus cos squared or something? No, it was simple. We had to put the 2 terms together to get 1 term, and then the trig ratios already worked out from that spot. When I mean trig ratios here, number 2, I mean if the right side is all in terms of cos theta, but we're in terms of sine theta, that's going to give us a clue that we have to change the form, and so that we're all in terms of cos theta. We'll see that in the next 2 examples. Okay, in this example, structure isn't as important. As you can see, we've got cos squared theta minus sine squared theta equals 1 minus 2 sine squared theta. Structure, the left side is already in the same structure as the right side, so we can put a check mark beside that, right? We've got 2 terms subtracted on both sides. But trig ratios, this is where this becomes much more important. If I'm going to start with the left-hand side, and in this case I would still suggest the left-hand side because there's 2 trig ratios to work with. If I look at my left-hand side, it's cos squared theta minus sine squared theta. focus on where we're going. We're going to this right side, which is 1 minus 2 sine squared. Do we see any cos squared there? No. So that's going to give us the clue right now that we have to get rid of our cos squared theta and get at everything in terms of sine theta. So I know that cos squared theta equals 1 minus sine squared theta from my Pythagoras identity. So I'll just place that in for cos squared theta minus sine squared theta. This equals 1 minus sine squared theta minus sine squared theta, which is 1 minus 2 sine squared theta, since there's two of those terms, which is the right-hand side. So again, by not even necessarily knowing for sure if we're going in the right direction, we just take a look at the trig ratios on each side, figure out where we are and where we need to get to, and that gives you your clue right there that you need to get rid of the cos theta and have everything in terms of sine theta. Last one here, and again, structure is going to be vital here. The left-hand side, let's start there again. Tan theta plus cotangent theta, and we've got to get it ending up to be secant theta times cosecant theta. So you'll notice when those are multiplied together, that's just one term, right? Because we can write these in fractions, and two fractions multiplied together, that's going to be one fraction, it's just one term. But we're starting with two terms added, so same thing from a structure standpoint, we're going to have to get a common denominator to add these two together. So a good move is to always write it in more of a fraction style, so we can change tan into sine over cos and cotangent into the reverse of that, which is cos theta over sine theta. Again, I've got two fractions added. The only way to combine two fractions to one term is to get a common denominator, so I'm going to multiply the first fraction by sine theta and the second fraction by cosine theta. So I'll get sine squared plus cos squared over the two denominators multiplied. Cos theta, sine theta. Hopefully that was pretty clear what I did. The common denominator is just the two denominators multiplied, so you have to multiply the fractions accordingly. Now, we're in our one term, which is great. This should jump off the page at you. Sine squared theta plus cos squared theta on top is simply 1. That's our Pythagoras identity. So 1 over cos theta sine theta. And here's where I would go, so we've taken care of structure, here's where I'd look back to trig ratios. I'd say, okay, I've got a cos theta and a sine theta on the bottom. Where am I going? Well, this is secant theta, cosecant theta. So you should think about that, and even if you don't write it down, think, okay, secant is 1 over cos theta, and cosecant is 1 over sine theta. So that's what I have to get to. Oh, these multiplied together, simply just 1 over cos theta sine theta, which is exactly where I am. So we can now show the grader that we definitely know that by staying on the one side, showing that this breaks out into two fractions. You probably don't have to show this. You could say right away that it's the right-hand side, but just in case, then you're really showing them you know your stuff. This is secant theta, cosecant theta, so it equals the right-hand side. Bottom line for every trig identity, use the structure to your advantage and use trig ratios to your advantage. Always have a particular eye on where we're going for the side that we're not working on, so that we know what to do with the side we are working on.